Hi everyone, this is Mike Yeoman, and this video is for my chemistry students to help prepare them for the final exam. There are a couple of pieces of information that we have not talked about in a whole lot of detail, so I wanted to get to that today to make sure that you have that information available to you. You were working on the airbag lab where you tried to build an airbag and fill it up with carbon dioxide from the reaction between acetic acid and sodium bicarbonate. Now, we're going to use that same equation as an example, but in that process, what we need to do is talk about a couple of things. And the first one is something called molarity. And molarity is very straightforward. It's a way to measure concentration. So we measure concentration in a lot of different ways. So parts per million, is a very common one. But in chemistry, one of the things that we use is molarity in order to measure the amount of substances in a solution. So I want to give you an example. If I took a pound of salt and put it into a liter of water. Okay, so that's a lot, and probably not all that's going to dissolve anyway, but let's just say for pretend that it all dissolved. So I take a pound of salt and I put it into the water, and we actually make it dissolve. That would be a saltwater solution. However, let's say I take that same liter of water and I put a tablespoon of salt in it. Is it still salt water? Well, the obvious answer is yes, it's still salt water, but those two solutions are not equal to one another. One of those is much more concentrated than the other. So molarity gives us a way of determining what is the concentration of those two different solutions. Even though they're both saltwater solutions, one has very different qualities than the other because of the amount of solute that is dissolved into that solvent. So molarity, which is symbolized by the capital letter M, is really just a very simple equation. It's the number of moles of a substance over the number of liters of a substance. So I could very easily turn this symbol of capital M into moles per liter. Okay, so that's fine when we're just talking about this in general, but to use your airbag lab, for example, we're using an acetic acid solution of 0.83 molar, 0.83 molarity. So I could also write that, since you guys are great at math, and you know that if you divide anything by 1, it is still that number. So I could put 0.83 moles, and instead of just molarity, I should have put of acetic acid. So if I put 0.83 moles of acetic acid, that's going to tell me how much acetic acid is in 1 liter of solution. So that being said, yeah, you're probably not going to use an entire liter, but this is just an example. And it's going to be important for us because if we need to figure out how much we're going to use, the acetic acid was in a solution. So in order to figure out how much we needed to use in order to fill up your airbag, we needed to calculate how many moles were going to be in that. So that's where this molarity comes in handy. So that's a very, very straightforward example. So on your final, each of you have a different combination of chemicals with different concentrations on them. So these numbers are going to be different, but you can use this same equation for whatever you want. So let's say that you had, a 0.4 molar solution of potassium nitrate, just to make one up off the top of my head. Well, I could rewrite that because I'm going to need to put this into my dimensional analysis in order to convert and find out how many liters I'm going to need. So 0.4 molar solution of potassium nitrate could also be written as 0.4 moles, sorry, that was kind of ugly, of potassium nitrate over 1 liter of potassium nitrate solution. Okay, so I'm trying to make sure that I use all my labels so that I know what I'm talking about, because otherwise if you just write moles or just write liters, then you don't necessarily know which solutions you're talking about, and it's very easily confused. But this is a very simple way to look at molarity, and we're going to use this in our calculation. So I'll create a follow-up video which uses this molarity to put into our stoichiometric equation in order to convert between what we're trying to find and what we've been provided. All right, so I hope this helps you with the molarity portion, and watch some of the other videos so that we can keep moving through and that you'll be well prepared for the final.